Chapter 3, The World of Numbers. Today we will learn decimal expansions of numbers. Basically, here numbers that we are going to discuss about decimal expansions are rational numbers and irrational numbers. We know that decimal expansions means when we divide numerator by denominator, then we will get decimal expansions. Accordingly, that we are going to discuss nature of decimal expansion of rational numbers and nature of decimal expansions of irrational numbers. So let's start terminating and repeating decimals. If we divide the numerator of rational number p by q by its denominator q, exactly one of two things will happen. Either decimal expansion terminates or repeats. Depending on that, we'll discuss the terms terminating decimals and repeating decimals. In terminating decimals, the division ends with remainder 0. For example, consider this rational number 3 by 8. After long division, when 8 divides 3, we will get 0.375 as a decimal expansion. Here, remainder becomes 0. Next, repeating decimals. Repeating means which is not terminate. So we can say terminating decimals as non-terminating decimal. Let's have definition. The division never reaches remainder 0. So whenever we are taking long division, means when numerator is divided by denominator, then remainder never becomes 0. And in this case, in the decimal expansion, a digit or block of digits repeats infinitely. For example, 1 by 3. Decimal expansion of 1 by 3 is 0.333, which can be written as 0.3 bar. For example, 5 by 11. Its decimal expansion is 0.454545 and so on, which can be written as 0.45 whole bar. 0. bar 45. So this is terminating decimal expansion and this is repeating decimals. So what we understood, in terminating decimal expansion, remainder becomes 0, whereas in repeating decimals, remainder never be 0. And when remainder is not 0, it means either digits are repeated or block of digits. Block of digits means here now two digits are repeating, 4 5 4 5 4 5. So this is block of digits. They are repeated. Now there is a one note. When the denominator q is a power of 10, that is 10, 100, 1000, 10,000, then decimal expansion of rational number p by q is terminating. Why so? For example, suppose we have 2 by 10. So its decimal expansion is 0.2 with the help of scientific form that we have discussed in previous classes. So remember, when the denominator q is power of 10, then decimal expansion of rational number p by q is terminating. Next, predicting, terminating or repeating decimal expansions of a rational number in the form of p by q without performing long division. So let's have the decimal expansion for a rational number p by q in its lowest form. Lowest form means p by q sharing 1 as the only common factor is terminating if the prime factors of q are only 2, only 5 or both 2 and 5. When the denominator q has factors only 2 or 5 or both 2 and 5, then we can easily convert denominator decimal expansion of rational number of the form p by q is of two types, means either it is terminating or repeating. So how to identify without performing long division that decimal expansion is terminating or repeating, that we are going to discuss now. The decimal expansion of rational number p by q in its lowest terms, that is, no common factors between P and Q, is terminating if the prime factors are only 2, only 5, or both 2 and 5. When Q divides P in the rational number P by Q, then decimal expansion becomes terminating. It depends on factors of denominator Q. When denominator Q shares only two factors, only 2, only 5, or both 2 and 5. Why so? Here is the reason. Because we can multiply numerator and denominator to make denominator a power of 10. As a, if we multiply 2 by 5, then we'll get 10. If we multiply by 2 to the 5, then we'll get 10. So whenever factor is multiple of 2 or multiple of 5, then we can easily convert denominator into a power of 10. And that's why that rational number P by Q becomes terminating. We will understand this concept with the help of example. Consider a rational number 3 by 20. Now here prime factors of 20 are 2 and 5. So 3 upon 2 square by 5. We will make 20 in terms of power 10. If I multiply 20 by 5, then I will get 100, which is a power of 10, that is 10 square. So multiplying numerator and denominator by 5, we get 3 into 5 divided by 2 square multiply by 5 multiply by 5. So 3 into 5, 15 upon denominator becomes 100, which is a 10 square, power of 10. 15 upon 100, which is equal to 0.15. So this decimal expansion of 3 by 20 is here terminating. No digits is repeating, no block is repeating. And in this case, remainder become 0. That's why if the prime factors of denominators are only 2 or only 5 or both 2 and 5, then decimal expansion of such factors or such rational number is terminating, because in denominator we can convert it to power 10. Second, repeating. If Q has any prime factor other than 2 or 5, then decimal expansion of rational number P by Q is repeating. For example, 4 by 13 will repeat because 13 is a prime factor which is not 2 or 5. That's why 4 by 13 that's why 4 by 13 has repeated decimal expansion. So this is the way to predict whether the decimal expansion is terminating or repeating without performing long division. So whenever denominator Q has factor 2 or 5 or both together, then only the decimal expansion terminates. Otherwise, it is non-terminating or repeating. Such type of example we have to solve in exercise also. Without performing long division, determine which of the following rational numbers will have terminating decimals and which will be repeating. Whenever such questions are there, we have to focus on factors of denominator. If the factors of denominators are 2 or 5 or both together, then it is terminating. Otherwise, non-terminating means repeating. So we have these three rational numbers: 3 by 50, 11 by 18, 3 by 8. Let's see our solution. The prime factors of 50 are 2 into 5, because 50 can be factorized as 10 into 5 or 25 into 2. So 2 into 5 square. So 50 shares only two prime factors, 2 and 5. So 3 by 50 has a terminating decimal expansion because we convert its denominator a power of 10. That is, 3 by 50 is equal to 3 upon 2 into 5 square. Now by 2, because 50 into 2, 100. So 3 into 2 upon 2 into 5 square into 2. 3 into 2, 6 upon 100, which is equal to 0.06. So decimal expansion here becomes terminating. Next rational number is 11 by 18. So prime factors of 18 are 2 into 3 square. Here we have a prime factor other than 2 and 5, that is 3. Even here we have prime factor 2. It's not mean that it is a decimal expansion which terminates, because prime factor should be either 2 or 5, not other than 2 and 5. Here we got prime factor other than 3 also. That's why its decimal expansion repeated. 2 is the only factor of 8. Now in rational number 3 by 8, only 2 is a prime factor here, because 8 is equal to 2 cube. It means 3 by 8 has terminating decimal expansion. How to convert 8 a power of 10? By multiplying 8 by 5 cube, that is 125, which is equal to 1000, that is 10 cube. So therefore 3 by 8 is equal to what? 125 into 3, which is equal to 375 upon 1000, which is equal to 0.375, which is a required decimal expansion for 3 by 8. Converting decimals to p by q form. In this topic, we will learn conversion of decimal numbers in the form of p by q, where p and q are integers, q is non-zero. Basically, here we are going to discuss three cases. First case of terminating decimal, second case is for repeating decimals, which further divided into two cases: pure repeating decimals and general repeating decimals. So we'll discuss here first case, terminating decimals. Whenever we have terminating decimal number given, then we have to write a fraction over a power of 10, and then we have to simplify. One more time. For example, convert 0.35 into fraction form. This is a terminating decimal number. Here two digits are repeating, 3 and 5. So we have to divide by 10 to the power 2, that is 100. So I can write 0.35 as 35 upon 10 square, that is 100. Now if we simplify this, 5 sevens are 35, 5 twos are 10, remaining 0, 5 zeros are 0. So final answer is 7 by 20. So 0.35 we have expressed in the form of p by q, where p is 7 and q is 20. So 7 by 20 is required rational number for the decimal number 0.35. So remember here, if n digits are repeating, then we have to divide by 10 to the power n. Next case, pure repeating decimals. First we understand what is pure repeating decimal. A pure repeating decimal is one in which a digit or a sequence of digits begins repeating immediately after the decimal point. It means what? After decimal point, immediately digits start repeating, or a block of digits starts repeating, or sequence of digits start repeating. For example, 0.8 bar. Here after decimal point, 8 immediately started repeating. 0.37 bar. Here after decimal point, sequence of 37 started repeating. So such decimals are called pure repeating decimal. Now how to convert pure repeating decimal into the form of p by q, where p and q are integers, q is non-zero. So here we have to discuss four steps. First step, let x equal to the decimal number. We have to assume in first step given decimal number as x. So here we will obtain equation 1 in first step. Now second step, we have to observe how many digits are repeating in second step, and by that power of 10 we have to multiply to equation 1. Multiply by 10 to the power n, where n is equal to number of repeating digits, and will give equation 2 that we are going to obtain in step 2. So in first step we assume given decimal number as x. Then we have to observe how many digits are repeating. The number of digits are repeating, say n, then we have to multiply equation 1 obtained in step 1 by 10 raised to n on both sides. Then we'll get another equation in step 2. We call this equation as 2. Now step 3, subtract the original equation from the new one. We have to subtract equation 1 from equation 2, and in last step we have to solve that obtained equation in step 3 for the values of x, which gives a rational number in the form of p by q. Let's discuss this by example. Convert 0.6 into the form of p by q. Now throughout here, whenever p by q is there, you have to assume as p and q are integers and q is non-zero. Here we have 0.6, which is repeating decimal expansion, and also pure repeating decimal. So first step we are assuming x equal to 0.6 bar. 0.6 bar means 0.666 and so on. Call this as equation number 1. Since here only one digit, that is 6, is repeating, only one digit is repeating, so we have to multiply it on both sides of equation by 10 to the power 1, that is 10. So 10 into x, 10x, and 10 into 0.6 bar. So after multiplying to decimal number by 10, decimal will shift towards right by one place. So this is equal to 6.6 bar. We call this as equation number 2. Now, as per the step 3, we have to subtract equation 1 from equation 2. Then 10x minus x, which is equal to 6.6 bar minus 0.6 bar. That is 10x minus x, 9x, 6.6 bar minus 0.6 bar, which is equal to 6. Now solving this equation in step 3 for value of x, dividing on both sides by 9, we get x is equal to 6 by 9. So here 3 2s are 6 and 3 3s are 9. So we obtain 2 by 3. Value of x is equal to 2 by 3. What is value of x? We assume 0.6 bar. 0.6 bar is equal to 2 by 3, which is a required rational number of the form p by q for the decimal expansion 0.6 bar. Let's have another example. Convert 0.45 into the form of p by q. Let's have solution. Let x equal to 0.45 bar. Here block of 2 digits, that is 4 and 5, is repeating. Since 2 digits are repeating, we have to multiply by 10 square on both sides of equation 3. So 10 square, that is 100. 100 into x, 100x. After multiplying 0.45 bar by 100, decimal will shift towards right by 2 places. Call this as equation 4. Now subtracting equation 3 from equation 4, so we get 100x minus x, which is equal to 99x is equal to 45 minus 0, 45. So x equal to 45 by 99. 9 5s are 45, 9 11s are 99. So therefore we got 0.45 bar is equal to 5 by 11, which is a required rational number for the decimal expansion 0.45 bar.